Hey everybody, how are we doing? I hit the UT Marvel screen, wrong button. Hey Isabel, hey Jake, what's up Emily, Michaela 8, all good to have everybody here. How is everyone doing? Looks like it was so bright. I noticed this yesterday. Oh, there we go. It's too bright now. I don't know. I need to stop messing with lighting. Hey Alex, good to see you here. One of these days I'll figure out how to do my lighting and it'll look normal. I won't look like I'm on fire. Like this, the right side and the left side of my face looks like I'm on fire now. Which one would you be able to go over problem number 3? Of course. Let's get some 320 pulled up right here and let's go over problem number 3. Can we go over question number 5? You bet. Question 3 and question 5. Let's talk about those. I might not give away the answer 100% here, but I'll go into it. Maybe that's good. I don't know. Such bad lighting. Let me just mess with the lighting. This is Brian adjusts the lighting stream and drinks his peppermint tea in his Mario mug. We got the Mario mug today. It's me, Mario. It's probably worst Mario impression ever. But let's see right here. Wording on number 4, you bet. Looks like we're doing some 320. It looks like a lot of 320 help. So I'm going to pull up 320 in the background. Hopefully, might have to like, am I still logged into Canvas? Oh no. I might have to run off. I don't know. My phone's outside charging. Oh no. Brian's going to get Thanos snapped away right here. Where's this? Uh-oh. Oh, it's going to happen. Uh-oh. I'll be right back. Be right back. I'm coming back. Coming back. 2 seconds. Okay. I'm about back. Totally forgot that two-factor authenticate, you got to have your phone on you at all times. You bet. A lot of 320, a lot of 474. Really good news, Alexandra. The office hours last week's, and I will do some probably near the end of this. The office hours last week's, Alexandra, have all the quizzes for 201. So don't worry, Alexandra. We've got help out there right now for that. And so don't worry though. We will try to do some of that today though. So good to see everyone here. Sorry I was ill prepared. You need your phone. Everyone knows two-factor authenticate. You need your phone. So let's run off and go grab the phone. We'll do some 320, we'll do some 474, and then we'll hop to 201. And let's do it. How is everybody today on this Monday? How's everyone's Monday going? I really want some coffee. I'm drinking tea instead, though. There we go. We got the assignment up and going. We are ready to go. I'm so glad to see everybody here. It's sometimes, if you notice, I'll do an off better than last Monday. That's good to hear. Busy can be good. Busy can be good. Let's hop over to the main screen right now. Let's do it. Awesome. I still haven't tightened down the camera. I noticed these small little changes. The things I say I'm going to do, and then I'm like, I'll tighten down the camera. It's so weird. I've had to learn how to be like a cameraman and how to do audio and stuff. It's a lot of fun broadcasting online. Got to learn all the little things. So not all the, you know what's going to happen here. Little bits. So let's do this. We're going to talk about BAS 320, question 3 to start. So this is BAS 320, question 3 to start. Am I in the wrong question? Question number 3, and I'll need to bring up the homework packet for this. So question number 3, here's the question. Let me bring up the homework packet here. Class is not over. This is just my, there we go. Well, that's the change too. It's one of those days. It's one of those days. It's one of those days when you're like, where is everything? Let's see right here. We are bringing up the homework packet as we speak. Class is not over. I need a different screen for when class is not over. Should say class is not over on the screen. Okay, we got the homework packet up. Let's do this. Boom. Here we are with the homework packet. So this is where all the homework questions are. That, not all of them, but a lot of them. And so I think question 3 is dealing with this right here. Is this who's some 320 who's wondering about this question right here with dealing with the bicycle kiosks? Is this the one everyone was wondering about right here? How are we doing on this right here? Is this the one everyone's wondering about? Question number 3. Get some yeses or nos in the chat. That looks to be it. Awesome. So what we want to do is we want to first understand a few things here, and this actually relates to 201. What kind of data makes this graphic? What two variable types would make a side-by-side box plot? And these are questions that are very fair on the test. There's things we should know pretty quickly. Like you should know how to graph and make data. It's a very important part of doing analytics, is knowing what kind of data you'll be making. So what kind of data makes side-by-side box plots? That's the first thing we should identify when we see this. We should say, okay, that's a blank variable. That's a blank variable. It makes side-by-side. Boom, Alex, right there, 100 points. Let's get MuBot loaded up. So it is side-by-side box plots right there. We're getting MuBot. MuBot is loading up. MuBot broke the world. He just destroyed everything. So quantitative will be scatter plots, which I think we have some scatter plots later on in other examples. We have scatter plots eventually. They had to be quantitative for us to have scatter plots. So many. Where's the fun graphics? So a scatter plot would be a bivariate quantitative relationship where a side-by-side box plots will be categorical quantitative. So categorical on the X, quantitative on the Y. And just to make sure, keep that straight, really good kind of quick test question to be like, what side-by-side box plots will show what kind of variables? Okay, so now that we know that, what about the plot suggests that there's an association between day and demand? Now I want you to think here for a moment. In what ways could things be associated? There could be differences in the what. There could be differences in the what. There could be differences in the what. In what ways could things be associated? In what ways could things be associated right here? I'm just going to sip on my tea. It's peppermint tea. In what ways could things be associated? Well, yes, great job, Charlie, right there, 100 points. With correlation, you are correct. There could be a positive or negative association. And this might help. What does an association mean? This is a really good thing we should know instantaneously. We've said about 3 times every class. What does an association mean? What does it mean for X to be associated with Y? It means that, tells you, what does it mean? What does it mean for something to be associated? And then we can kind of put it in context here with the days of the week and the demand. So what does it mean if something has an association? Something about Y is explained by pretty much knowing X gives you information about Y. And Alex, you're right. Alex, 100 points. We all have different ways of saying it. That you're right. Y is explained by X in some way. That maybe knowing X narrows down the values of Y. What if I told you there was an amazing day where we had so many sales of bikes? These are bike kiosk rentals. So there were so many bike kiosk rentals. What day would you think it was if I told you, oh, there was such an amazing day where we had so many rentals of the bikes? What day would you think it is? If I said, wow, there was such a great day where we had so many rentals. It was through the roof. It was insane. Saturday, look at that right there. Saturday has the highest maximum. So you can see here that Saturday has a bigger range, Thursday has a smaller range, and Tuesday might actually have the smallest range. You see little differences between the medians. There is some difference. You have to zoom in a little bit. But notice how if we know what day it is, it gives us some information. Like Saturday has the highest median, also has one of the greatest ranges, and has the biggest maximum. Meanwhile, Tuesday has a slightly lower median and a slightly smaller range. So these box plots are not identical. That's key right here. If the box plots were identical, then you would have no information. Like the purest way to see, what are all these? I was trying to get more pens, and I think I broke Word. Someone else online was like, where are my pens? And I was like, that's the question I want to know. Where's the answer to it? And then the Microsoft help told me to do something, and it didn't help. If your box plots looked like this, and this is, you know what I could do? You know what I could do? Oh, look at that. Oh, they're identical now. As identical as you say, Brian, that was a little higher. I say, okay, there we go. So now the box plots are identical. Oh, space pen, why did we not? Space pen's going to show us where there is an association. Now we have some sort of association right here. If we have space pen here, space pen leading the way, best pen there is. Rainbow pen fights space pen though. Space pen wins though. So right here, we have a difference here. We could also see other differences where maybe there's a difference between the averages or the, so not the averages, those are the medians. Yes, everybody loves space pen. Nobody likes rainbow. I'm sorry, rainbow pen. Now we have a difference in the spread. So now there's a difference between them in both their medians and their spread. Remember, the box plot shows the 5-number summary. Space Pen OP, Val, please nerf. Nah, Half-Life 3 is going to have Space Pen. You just throw Space Pen and it just everything. Half-Life 3 comes out next week, I think. That's what I heard. Heard a rumor. They're just going to drop Half-Life 3. It's going to be in an arena. It's going to be an arena battle game. That's what Half-Life 3 is going to be. It's going to rival the Fortnite kids are playing. I should not act old, lest one of these days it's not funny. Okay. So when it comes to the F statistic right here, the F statistic is, and we talked about this last class, the F statistic is the observed over the expected. So we take the ratio of what we observe the variation between the groups being, and then we look at what we expect. Now, if we go back in time right here, if we go back, we still got this right here. What do you think the F statistic would be for this right here? What would the F statistic be for this? Very important to know how the F statistic's calculated of sort, theoretically. Charlie, it's just review. It's just review. No, I know, Charlie. Don't worry. I try to keep on top of what students are feeling, and I know there's been a lot. And please keep asking questions. Please keep reviewing. Keep taking notes. And I appreciate everyone working really hard, because I know everyone's working really hard right now. And I feel like a lot of we want to keep everyone working, but in that we put a lot more work out there. And so we just want a quick aside. We were planning on having quizzes in 320, like weekly quizzes, and we haven't done that yet because I've been feeling, we 320, 474's had more work, 201's had more work, and 320, sorry, 474 and 201. But 320, I can tell, especially with the initial start to coding, which has always been a big bump for 320 students, I couldn't put any more work on your shoulders. And I just wanted to say, keep up the good work. I know everyone's working really hard. So Charlie, Vols help Vols, we got you. Keep asking those questions. Keep working hard. You got it, Charlie. That's my pep talk. And please, take time for yourself when you need it. Yeah, I know, Mikhail. I feel that too. And I don't want the students to feel that we don't care, because I promise you, I try to stay and I read as many things as I can. I go to Reddit and I read what students are saying and how they're feeling, to kind of take in at least one view from students. That's one view from students. So, and I try to make sure I kind of understand. That's the best I can do. Yeah, so we got you. We're here for you. But so keep asking those questions. You got it. Let's do this. So who knows what this F statistic's going to be? Who knows what this F statistic's going to be right here? Who knows what this F statistic's going to be? Any ideas? Look at it. There's no variation between the groups. Let's plot out what the F's going to be. The F is the observed. Close. That's a good guess right there, Alex. Alex, that's 100 points. We're just throwing out all the points. Michaela, you're right. It's 0. Because there is no variation between the groups. The F is going to measure the variation either between the means or the medians. You can do either one of these to get a discrepancy right here, and there's no. So the observed variation between the groups is actually 0. So although that is an O for observed, we could make it a 0, which, funny enough, looks identical to the O. So it's basically 0 over expected. So we observed no variation of what we would expect. Is that making logical sense to people right here? You won't have to calculate the F. In Charlie, are you 201, right? Charlie, if you're 201, then don't worry. The F, you will not deal with the F statistic. Yes, when you said chapter 7, I was like, wait, that's 201. Good news, Charlie, you won't have to deal with this. And by being here and listening to this, you are getting some reviews. So I know you're like, oh, no F statistic. So can you work on assignment 2? You bet. We're going to go through some of this assignment right here. Yeah, Charlie, okay, Charlie. Charlie just took a big sigh of relief right there. Charlie, that's 200 points. I'm so glad you're here and asking questions, and you didn't just turn off the video and said, well. So let's look at this right here. Let's think about this. And Charlie, we're actually going to mention something for 201 right here, because we're gonna talk about a concept. Check this out. We're going to draw. Here's what we're going to draw. We're going to draw 3 things side by side, and we're going to relate them. We're going to keep working through 320, then we're going to hop to 474, and then we're going to do some 201 at the end. So I want you to think, if the F is here equal to 0, then I want you to tell me, I just need a guess. We're not going to calculate it exactly. Can anyone tell me what the F right here would be equal to? Just take a guess. Just a guess. What is the f down here on example 2 going to be equal to? What is the f on example 2 going to be equal to? What would it be equal to? 4? Yeah, let's go a little higher. Let's go a 7 or 8 or like a little higher. But 4 is good enough. Don't worry, it's just that there is differences. I'm going to go with 7, just a little bit more. You know what? You said 4. Let's go with 4. It could be 4. It just depends on sample size and all different factors. But now we want to think about this. Here's a concept that Charlie has probably heard in 201 is p-value, which is what we're going to lead into in this question. So when we think about the p-value here, how do we get our p-value in 320? What procedure do we do for 100 points? What procedure in 320 do we do in 320 to get our p-value? To do randomness. Permutations. So the permutations, Alex and Michaela, both you get 200 right there. We're just going to give away all the points today. If you're coming to office hours, you're doing exactly what I want you to do. It's a great time to ask questions, go through it and review. And here, I'll put this one down here. Basically, if this is the same sort of data, it would lead to the same permutation results. And then we have to plot right here. Nice job, 8. 8, you get 200 also. So we have to plot right here where our F statistic is. And I'm going to use the red pen, sorry, space pen. But the red pen, or the red crayon, is going to be where we observe our result. So this is the way the graphics look inside of R, is we have our result. And now the p-value will be the area shaded to the where on this. The p-value will be the area shaded to the where. The p-value will be the area shaded to the where of this. To the right, Michaela, great job. So the p-value is over here. And can anyone tell me the p-value for the first graphic? What is the p-value? We'll use space pen for this. So the p-value for the first graphic is equal to, this one we can compute pretty easily, is 1. You're right, Michaela. Yep, because it's 100% of the curve shaded. So Charlie, look, boom. See, like p-value is the probability of our results must be dependent by random chance variation given the null is true. It's like quote number something, MuBot. No one's talked to MuBot today. MuBot is going to be sad right here. I found out we had 2 MuBots running. That's why I was saying 2 quotes. Or Andrew, so feel free to talk to Andrew. And then the p-value down here, I'm not saying it is this, but this is an estimate. Like, it'd be like 0.01. I know I can't actually compute it with this graphic, but does it look small? It does look small. So the p-value there is very, very, very small, meaning that this difference, what does that mean about the difference over on the left? What is it? So the top one is not significant. So this one over here is not significant. And this one down here is statistically significant because it's less than 0.05. And that means that this difference, so I can go to the other side. Watch this. Do I have a Brian over there? I do. So this difference between the two of these is unlikely by random chance, where the difference up there on the top one is likely by random chance. So the top one has a difference that is likely by random chance. The bottom one has a difference that is unlikely by random chance. Bingo, Charlie. I think you're seeing it. When the p-value is less than 0.05, it is statistically significant. So think about this. We're saying that the difference between these graphics right here, the difference between these is unlikely by random chance, that we think, and think about this, what does the F tell us? That the observed variation between the groups is what? Interpret this F statistic. Who can interpret, let's say this is test A and test B, and we're looking at the scores on the tests. How would you interpret that F statistic in context right here? The observed variation between the tests is what? The observed variation between the tests was what? And this is the interpretation of the F statistic right here. The observed variation between the tests was what? I'm almost out of tea. The observed variation between the tests, it is statistically significant. That's the p-value. The p-value tells us that it is statistically significant. The F is going to tell us that the observed variation between the tests was this many times something more than we. So it would be, think what the F is. I'll give a hint right here with rainbow pen. The F is the observed over the expected. So how could we use this to talk about what we blank was blank for what we blank? What would go in there if the F is a ratio of what we observe between the groups over what we expect to observe between the groups? So You're right there. This is a good thing. We put this on the test like an interpretation of the F statistic. So good to see here, Griffin. 100 points, Griffin. And so 8, you're on the right track. It would be that the observed variation between the groups was 4 times more than we would have expected via random chance. Think of it this way. Yes, bingo. Michaela, great job right there. What if I'm going to tell you I'll pay you $10? If I say I'm going to pay you $10, then $10 is what you expect, and then I pay you 40, then your F ratio right here would be 4. So what you observe getting paid was 4 times more than you expected getting paid. So when you think about it between the groups right there, over on the far left graphic, you see that the differences, or excuse me, the variation between the groups was 4 times more than what we would have expected via random chance. And up here, you see the variation between the groups was 0% of what we would have expected via random chance. There was no variation between the groups, and this no variation would probably just be due to random chance, because it's like, well, maybe these people took a test A and a test B, and the grades are not dependent. And does everyone see which of these shows a no association? Which one, number 1 or number 2, shows no association? Which one, number 1 or number 2, shows no association at all? Like no association. It would be graphic number for 100 points. Which one shows no association? Graphic number 1, Charlie, great job. Great work right there. And you see that these differences would be likely due to random chance. There is no differences, and we observe 0% of what we would have expected. And then down here on the bottom, we see a large difference that is unlikely by random chance. And I put in some theoretical numbers, but the variation between the groups was 4 times more than we would have expected. So we're like, yeah, I don't think this variation between the groups is likely by random chance. Charlie, I'm putting you to your 1,000 points of the week. You're in tool 1, and you're answering the questions. I love it. That's awesome. Keep up the good work. So with this right here, I think we've answered most of the questions. The F statistic right here, who feels confident that they could explain what this F statistic is? We've gone over some interpretation of what the F statistic is, so I hope you feel confident on this one. So I understand you are just comparing 2 box plots for this example, but are we supposed to compare all the box? So the variation in demand between days was, then we would have, by, does that make sense right there, 8? So the variation in demand between is, does that make sense? So because you could say the variation between tests, where's everything? So the variation between tests, the variation between grades on tests, the variation on grades between tests, version A, version B, and we could put a version C in there, was 4 times more than we would have expected via random chance. And so if you use the same sort of wording, it should make this answer pretty obvious. Are people feeling decent on how to interpret the F right there? Feeling a little bit better? A little bit decent? How are we doing on that? All right, maybe? I'll hope. Good, good, good. And then right here, how would we plot the p-value? Does anyone know how you could plot the p-value, which is not a bad idea? Oh no, yeah, keep working on it and let me know. I can't tell if there's any data from 4.5 on that graphic. Yeah, there's basically none. It's very little to none. So there's 5,000 permutations here, and if there are any data points here, it's next to none. So drop your line, and then what do we do once we drop the line? Once you drop your line right there, what do you do next? To get the p-value, you plot the line, and then you do what? Shade to, exactly, look to the data to the right of the line. Michaela, great work right there, 100 points. And you'll see this is an example like the lower one where we have a very small p-value, and that should indicate statistical significance or not. I'm not saying which one it is, but it'll tell you it's statistically significant or not statistically significant. And so management only cares about demand, vary from day to day of 1,000. So one big thing I want to mention right here is something must be what first to be statistically significant? To be practically significant. To be practically significant, something must be this. To be practically significant, you must be this. I.e., you can't be by random chance. Statistically significant. So we've determined it's statistically significant. Just saying. And right here you see we have differences. Now you might want to look at some of these days right here and then look over at the side. Now notice that this is in units of 2,000, and that's about 1,000 right there. Now these differences right here, do they look to be a difference of about 1,000 between the days? That's what you want to look at right here is be like, okay, do these differences right here, do they look to be about 1,000 between the days? And I'll let you decide, but I think that'll tell management if they care about it or not. So we'll look at that right there. True false is, I might not mention too much on these, but we have gone over some stuff already that something has to be statistically significant to be practically significant. How do we know if something is statistically significant? Like we should know instantaneously like this. How is something statistically significant? How is something statistically significant? Very, very quick and easy for 100 points. You should know statistical significance like this, less than 0.05. Boom, Michaela, another 100. Just getting all those hundreds, get that 1,000 points. If it's less than 0.05 p-value, then yes, it is statistically significant. And 0.05 is the assumed alpha, which, unless you're playing around with results, it's 0.05. And then the last question, be very careful. We are going down to this one right here, the EX tips. This is the last question. You won't be doing the correlation this time. That's on the next assignment. So what we have here is people's tips, and we're going to predict people's, what is it? Tip percentage. Wait. We are curious whether smoker, can't find it. Party size. That's it. Since there's no confidence interval, can we say for sure though? Good question. So it doesn't talk about confidence. And here, Michaela, we'll bring that up again here because that's kind of a big part to this question. So I'm going to run the code for it down here. We've got all this, just random fake ID. And sure, why not? You need to put in your own. My ID is 1. That's my idea. And so let's go here. Let's load up the data. Let's make our random subset. And we have this right here. Now, a few things I want to mention is do not give excessive output. The graders have actually been really nice lately, and they're supposed to take off points, but they haven't. So good. But they're supposed to take off points if there's a lot of excessive output. And I don't go through and regrade homeworks and lower grades unless there's some, like they entered 100 and you didn't give the homework. Then I'd be like, oh, you didn't even turn anything in. The grader gave you 100 by mistake. So I don't lower grades unless there's a huge error. But I'm not gonna, we don't want tons of output. So watch what I'm doing right here. So I'm running the associate function, which is found inside the library reg class. If associate is not appearing for you, make sure you turn on library reg class. Don't worry, email me if there's issues, but I've gotten a lot of emails. Don't worry if it's you. But a lot of people say, Brian, associate function is not there. And I say, run library reg class. So don't worry, email me. It's better than spending 20, 30 minutes, an hour stuck on something. Just email me. So the way the associate function works is the associate function uses y tilde x comma, not c, data equals. So this is the format of associate. We put the y variable in, then we do tilde. So this is a formula right here. We are using y as the y variable that we want to understand, x as the explanatory variable, and data equals is going to be our data frame. So I'm just going to put df there as a placeholder. So let's go ahead and take a look at what we're going to do by putting this right here. So now we have our y variable, which will be, it'll be party size. Sadly, I have to go to class. Oh, no worries, Alex. We'll put some timestamps in this. Come back and check it out. And we will see you later, Alex. Party size. We're going to look how to spell it. Size of party. I totally butchered that. Of party. There we go. Double check over here how it's spelled. And then X right here is going to be smoker. We're not going to misspell that. And then the data frame is EX2 tips. Now, here's something you should put inside of here is you should put the following. You should put, this will help, you should put seed equals and then put in a random seed. Let's just go that. Sure. Plot margins not large enough. That happens when this is not large enough. And let's do it here and we'll run it. Now, here's one thing I want to point out is that my current configuration will have the code print down here. Yours might print out the results below the chunk. I've had it. Don't worry if you've emailed me. It's all right. I've had people email me and say, Brian, I don't have all the results. Your results are likely below the chunk. I can send you my configuration, but this is just the way I like my output to be. Everything down here, you have to go to tools and you have to go global options. I think we can do it now. Tools, global options, and R markdown. So right here is what you want to have your configuration. If you want it to act like mine, it's all right if you don't. It's just personal preference. But this is the way my output appears such that it appears in the bottom console. So if you make yours look like this on my screen under your tools, global options, R markdown, you will receive output the same way mine is. Let's hit cancel. So all my output appears here at the bottom. I don't want it to wrap around the screen. Can I get it so it appears and doesn't wrap around the screen? Perfect. I love it. So what do we have going on right here? We're doing a test on the means. So what you want to do here is take a look at your p-value. So since it says we're testing the means in this question, is this statistically significant? Question number one, is this statistically significant? Is that p-value statistically significant? That's question number one. Most people do that one perfectly fine because we've been talking about that all day. Is that p-value statistically significant? No one knows. No. P-values we should know pretty quickly regarding whether or not they are statistically significant. There's a standard we use every time, and we want to look at this estimated p-value. One quick aside right here, it's an estimated p-value because we're using the permutation procedure, which we can see down here at the bottom of the screen. I'll probably go through the output here in a second, which will be very important. You know what, we'll do that right here because everyone should know everything in this output. So let's go right here and talk through all the output, just to make sure everyone knows what's being displayed. So when we look at this output, we see the association between smoker, categorical, and size of party numeric using 243 complete cases. That just means every row has data in it. Sample size, we have no was 150 people for not smoker, and yes was 93 people for smoker. Then we go here to the ANOVA, which compares the averages. Now, you don't have to know that an analysis of variance is going to compare the averages, but you need to know that we are comparing averages right here. That's more important. If you notice right here, the no group had on average 2.673 people in the party. And you say, well, how's that possible? Well, there's a lot of like parties of 1, 2, 3, 4. You can see right over here, it is discrete data as in whole numbers. But when you average it out, it's like on average, we have 2.673 people in the no smoking party group. And then we see the yes smoking party group had on average 2.409. So this gives us a discrepancy, which means this is the F statistic that we see the variation between the groups was 4.5 times more than we would have expected due to random chance. So that's kind of large right there. That's 4.5 times more variation between the groups than we would have expected. Right here we see the p-value, which tells us the statistical significance. We do the mean ranks right here. If we give numbers ranks, as in we say this is the lowest, so it's first, and this is the second lowest, it's second, and then this is the highest. So I think there was like 250 something, 243. So then that would be the 243rd. So this is comparing the average rank. We don't do the Kruskal test right there. And then the medians we sometimes do. If you notice, there's no difference between the medians, which makes the discrepancy super duper small, basically 0. And since the discrepancy is 0, the p-value is 1. This literally relates to our topic right here that we got an F of 0. I think the issue, Isabella, look down below, and I think you'll see it down here. Don't worry, that's a lot of people have emailed me about this. Do you see the output below the chunk? And if you click through the windows, you should see it. Isabel, 100 points. Thank you for asking. A lot of people have emailed me about that so far. Do you see it below the chunks? So look below the chunks right here. That's when I don't turn my ringer off. So look below the chunks and see if you see it down there. And it should be right below the chunks. And you can click through it. Next, we go right here and we see a confidence interval. So what does this tell us right here? Although our p-value for the ANOVA is statistically significant, it might not be statistically significant. Because look at this. If this p-value came back, we'd say this is statistically significant. And if this p-value came back, we would say it's not statistically significant. The Kruskal-Wallis just Kruskal-Wallis. The Kruskal-Wallis also has a p-value that could be below 0.05 or a p-value that could be above. Remember, we're making an estimated p-value. We're saying, I'm going to estimate the p-value. I think when I told a student this, and I think it helped them, imagine your friend says, I think I'll make it to the 5 p.m. meeting. I'll be there at about 4:55. But there's variation. I might be there at 5:05, so I might be late, or I might get there at 4:45. Like, I don't know because there's variation. I'm unsure of when exactly I'll get there. So with that, we're saying we think the p-value is this, but it could be as low as this, or it could be as high as this, because remember, we're estimating it. So when you look at these intervals right here, it's giving you the lower and the upper end of what the p-value could be, and we want this p-value interval to what? This is huge right here, because this isn't a p-value interval that's inconclusive. You got it. Great job, Isabel. Why is this p-value interval here inconclusive? Why is this one inconclusive? I'm just going to keep making that noise for some reason. Why is this p-value interval here inconclusive? Why would this p-value interval here be inconclusive? And the big reason is, and that's basically it, because it goes above 0.05. Not just above, but it contains, since this is below, the top end of the interval can't go above. We want the p-value interval to not contain 0.05. We have some good notes on this on previous classes and streams, but we don't want this interval to contain 0.05. So both of these tests right here are inconclusive because 0.05 is in the interval. And it literally says that right here, and then it gives other advice. Last but not least, we will, when we redo this, and make sure to include both these results and use seeds. Please use a seed. It'll make it so you can talk about your results and they won't be random. We will go to 5,000 permutations and we'll rerun the results. Now, this will make the interval tighter. It won't necessarily make the interval lower or higher. It just makes the interval better estimated. And so we have a better estimated p-value, a better estimated interval, as in more samples, creating a tighter interval. And we do see that the interval is completely below 0.05. And look what's right in the middle of the interval. That's the way intervals usually work, is they're usually somewhat symmetric. And we see here that 0.035 is in the middle of this. So if you wrote this in Stat 201 as an interval, you'd write 0.035 plus or minus 0.005. And so that's the interval right there. It's like, I think the p-value is about 0.035, but I don't know. A little plus or minus of 0.05 on it. Like, well, it might be 0.04, it might be 0.03, but guess what? This whole interval is now below 0.05, which means it's conclusive. The interval being below or completely above 0.05 means it's conclusive. The interval containing 0.05 means it's inconclusive because we can't say for certain it is statistically significant or not. Last but not least, we should just briefly mention this output right here. And I'm going to have to make the screen way bigger so it doesn't block the permutations. There we go right here. Let's rerun the code. And so we're just making it so we can actually see the results down here at the bottom, because for some reason the graphics block the results if you have the window too small. So now 3, 2, 1, do it. Show me the result. There we go. So here are the results, and we can actually see the bottom permutations. Since there is no confidence interval on number 4, can we say for sure? Oh, yeah, so that one doesn't ask for certainty on number 4. Oh, yeah, no, just look at, good question, Michaela. Those are the trues and falses. The question of is something statistically significant can be simply done by the p-value. The questions don't ask about are you confident. So don't worry about that, Michaela. It's not a trick question. So if the p-value is like 0.03, statistically significant. If the p-value is 0.32, not statistically significant. So just make sure the only questions that need code is 2 and 5. I think so-ish. I don't want to say for certain. Maybe. I'd have to look. I don't know all the questions. I mean, I know all the questions. I know you're doing conditional and marginal distributions, though, can be done with, yeah. Number 1 is telling which one is X and Y. That doesn't need code. Number 2 is conditional and marginal distributions. That doesn't need code either. Technically, you can do it with code. And then number 3, didn't we just do? Number 3 is the bicycles and days of the week. So that one doesn't need code because you get everything provided. Number 4 is the trues and falses. Number 5, I think you are correct. Number 2 and number 5 are the only ones you really have to code stuff for. You could code stuff for other ones. There are other ways to do it. Good question right there. 800 points. Making me think. Like, I was like, I had to think through all the questions. Good question. So up here we have the box plots. Now the question tells us to use averages. So what should we look at to compare the averages? Should we look at set of graphics? Where am I at? Should we look at set of graphics 1 to see if we want to compare means or medians, 2, 3, or 4? So which line of graphics, I've asked this many times on the test, should we look at to know if we should compare means or medians? Now, the question says use means, but if we want to know which one we should use, should we investigate first line 1, line 2, line 3, or line 4 to see if we should compare means or medians? This question just obliterates people on tests. Like, I'll tell people it obliterates them, and then they'll just be like, should we look at, if we need to know, should we compare, like, to investigate, should we compare means or medians? Should we first look at line 1, line 2, line 3, or line 4 to investigate whether we should compare means or medians? Awesome. Yeah. No, it's a lot more association stuff now. Which line should we look at? Line 1, line 2, line 3, or line 4 to investigate if we should use means or medians? This question just on the test, people, I could narrow it down to 2 lines, and I think half the people would still get it wrong, or more than half, which scares me because then it's like, are people just guessing? Ah, that's what a lot of people think. A lot of people, don't worry. Good 8, another 100 points. A lot of people think it's line 2. Does anyone have another guess? 100 points still on the line. Not line 2. You won't look at line 2 to figure out if you should compare means or medians. No worries. This is why I asked this. And this is why I leave this question hanging for a moment, because it's one of those questions that just people forget to. I mean, it's something new in this class. We talk about it in 201 actually a little bit, but the answer is line 3. Line 3 is the QQ plots for normality. So it'd be line 3. So line 3 is when you gauge normality, and the QQ plots for normality will, like if we do normal data, and we do random normal, and we do 500 random points, and then what is it? Random exponential. And then we do 500 random exponential points. And then we do QQ plots of these, which please work today, QQ plots. Sometimes it's like, nope, you have to reset R. Good. If you notice, this one right here follows the red line, and that means it's pretty normal. And this one right here doesn't. So you can see behind my head right here, you have the versions of it when it is, and I'll go away here for a second. So the QQ plots, we look at them for how closely it follows the red line. And if you look right here, this one does not follow the red line, so it's not normal. This one does mostly follow it. Don't worry if there's a little bit of bend outside or you see points on the outside. We could like rerun this. Yeah, exactly. So when you look at it, if we have to investigate to use means or medians, this is a clear case of medians, and this is a very clear case of means. So if it follows the red line, mostly means. If it doesn't follow it, medians. And why do we say that? Because this red line right here is the normal curve. Just so you can see, going back in time right here, this plot would relate to this one, where if we did one of this histogram here, that's when we would get this sort of plot. You see how it's right skew? Then we get one that doesn't follow the red line. So if it doesn't follow the red line, it's going to have some shape that's not normal. And if it does look normal, it'll follow the red line. So the one that follows the red line has this shape that is normal right here. And the one that doesn't follow the red line will look skewed. So hopefully that makes a little more sense. A lot of people will get that one wrong, especially on the test, understanding the differences. Well, I think it covers pretty much all of 320, like the big concepts for this week. I think everyone's feeling better about this assignment. Was this assignment a little bit easier, a little less time, a little less, I don't know how to do a question, maybe, I hope. Who is here from 474 or 201? 474 or 201. Not 471. I don't teach that class. If you're here from 471, I don't know how to help you. 474, what questions do you have, Emily? What questions do you have, Emily? Which ones? The while loop, the break. You know what's really funny? I wrote a plagiarism checker. Question 2C and question 3. Yep, we got 2C. You got to, let's do this. Chloe, good to see you here. Chloe, Jake, and Emily, 100 points to each of you hanging out here while we do some work. And so let's go over here. You know what? I might play that Smash intro today for 201. The thing is, if I play for 201, I'm not going to play it for all the other classes because I'm afraid if we get hit with a like copyright claim, I just need to do it for 201 and then see if Nintendo hits us, because they'd only hit one video. They wouldn't, like, I'm afraid to do it for all the videos, and then like every video gets hit with a copyright claim from Nintendo. So, oh, thank you, Jake. Yeah, you probably saw it in the Discord. I'm glad you liked it. I did a new thing today. Or if you saw it last night. So check out the newest video on the channel, and there's a Smash Bros intro on that too. So we had a lot of fun with that. And let's go here. It's fun making stuff. Like I find it to be exclaim. There we go. Okay. This one right here is using a for loop and if statements create a categorical variable called exclaim that equates to none is this, low is this, high is this. Provide a summary of exclaim. Okay. I think I can do one very similar to this without doing this problem. If you think about this, so I want to do one very similar, and then I like doing similar problems because then you have to think through how to do it. And so check this out. Let's say I want to relabel people as tall, very tall, or short, or something like that. Let's just say I do that. So we go here and we go to data survey 10. So this loads up the data right here. And what does it want us to do? It wants us to do a for loop with an if. Okay, so that's less fun. So how do we write for loops first? What do we do when we write a for loop first? How do we start out by writing a for loop? This is key. How do we start out by writing a for loop? How do we start out by writing a for loop? So very key here to this question. Most important thing when you write a for loop, you write the skeleton. Emily, 100 points right there. Write the skeleton. So I'm going to go here to the first observation, and I'm going to go to let's go to their height, I said. And we're going to go to the first observation. They're 72 inches tall, 6 feet. And let's go to the first observation right here and write, if this person is greater than or equal to 72 inches, then we'll run the code where we go into eval. Let's call it eval. Eval equals to, we're going to store them as tall. Can't type. And then we can go here and do another condition and say if this person right here is greater than, and let's go to 60 inches, and also they need to be, we're doing another condition, and they are, be careful, the ends and the ors are important here. So if they are greater than 60 inches or less than, we don't want less than or equal to, they are less than 72 inches, then we'll store into here medium, and then we'll go here. You know it's going to work better if we take this one. And then we want, if they are less than 60 inches, let's store into this short. So we've kind of got, basically, someone who's 4 feet tall, 5 feet tall, 6 foot something, or it could be 6 foot plus. So we've called people tall, medium, short, and just descriptors. I mean, if you're 5 feet tall and you're 10 years old, you're ridiculously tall. So there's, does this work perfectly? It's just an idea. It's just labeling things and recoding stuff. So when I run this code right here, the only code that's going to run is, these are all kind of, they're disconnected. They're disjoint, I should say. That's the proper word in statistics, because you can't be tall, medium, and short at the same time. You can't be more than one category, because tall is 72 and above. Medium is 60 to 72, not inclusive of 72. And then short is everything below 60 inches. And so now I'm going to go here to eval. I'm going to store in result right here. And result position 1 is going to be eval. Result does not exist. There we go. Now it can store into it. I made the thing that exists that needs to store into. So what have I done here? I've created the skeleton. This needs to be not here. And that's just kind of starting work, because we're not going to keep running those over and over again. We don't want to remake the result vector, because that would clear out what we had. Like if I run this every time, it'll clear the result vector. I've done that before. Very common issue. Put something in your for loop that should not be for looped. And now if you notice right here, the only thing that's going to change is going to be this and also this. So if I run this right here and I take a look at result, we are getting the results. So can you kind of tell where my placeholder's at? Here's how you can tell if you have the right spot for your placeholder, is you do a little cleanup work and you run everything again and it's working. And then you go here and you go I is 4, and then you put I's in. And make sure if you're using 2 placeholders for like another question within for loop and a while loop, you don't use the same placeholder. So now we see if it works, and it is working. So I could just sit here all day and run this code, but I've basically created my skeleton. Does this make sense what I've created right here? I've created something and I'm testing it out that it works. Now the only thing I need to think about is what goes inside the for loop. Who knows what lines of code would go inside the for loop right here? It'd be pretty interesting if I put one thing inside of it, but I shouldn't do that. I mean, it's going to create unnecessary output. What will go inside my for loop? What lines of code will go inside the for loop right here? I probably have enough time for the next question too. We got it. My hair is going all crazy. It's just going to keep getting longer. Till I got it. Till we get the mullet. Till we get the mullet. Everyone really wants the mullet. I've advertised it. It will happen. There will be a mullet. And then Brian will be like medium, shortish hair Brian. And I'll be sad. What lines of code go inside the for loop? Because this is theoretically exactly the same as your question. Like I like doing one that's so people can't copy down exactly what I do, but the theory here is identical. So what we want to do is we want to take these lines of code because this is where it's going to finally end up storing it. This is where it does the testing, and then whichever one is stored into eval will be stored into the result for the position I. So we're going to go to the for loop right here, and we drop our code in. We're going to reformat. You can go to code, and let's go to reformat code. Ooh, don't want that. Reindent lines. Code. There we go. Don't want to do that. And so with this right here, let's take a look. Our variable name is I. The vector I will go through 1 through the number of rows in survey 10. And it ran. There we go. It worked. And there are people who are below 5 feet. So we did everything right here, and we could print out a table of the results. So we go right here, and we run a table of the results. And there we go right there. We got everything we need. Is this making sense? Who feels like this helped out maybe with 474? Did this make sense? And are people seeing the structure to this to kind of do the betweens? Because I think you're just checking out to see how much exclaim makes sense. Good. That's what I want to see. Yep, it helps. That's what I want to see. I want to kind of like do one very similar and notice the way we coded it. That's kind of key is you start by just making it work on one instance. I know there's this like, don't worry, I used to do it all the time. Like no, I was actually just doing it yesterday. I wrote a plagiarism checker. I think I could show it. Let me see right here. I'll show everyone what I wrote real quick. So I was using for loops. For loops are so important. I think this will be good. Yeah. I think everything. Okay, cool. So this is the plagiarism checker I wrote, and it's reading in Word documents. I created a data frame with my name in it, and then it's going through and reading in all the like who created it and everything to check for plagiarism. And this isn't going to be like, yes, this is 100% plagiarism, and there's a lot more to it. But it reads in R your Word documents and looks at all the metadata inside of it and compares and makes tables of people who created Word documents. If you look, it's all inside of a for loop. So how many Word documents do you think I got this working on first? Just think about what I did first. Is I got it to work on one Word document, and then all I did was go through all my Word documents. So all I did was get it to work on one Word document, and then I made it work on all the Word documents. And you can see a lot of similar formatting here, where I'm kind of creating a repository for it, and then I'm using row bind right here. So kind of neat stuff right there. But I just always wanted to have a plagiarism checker like this that would look for the people who created it and modified documents. And it doesn't mean someone cheated if there is an issue. Like it could be a roommate, it could be family, it could be different things. But it looks through and sees if there's any like issues of concern. And we should, I don't know, it worked really well. I was like, oh, good. Because I had thought about that a long time ago, and I don't think my R skills were up there. But it wasn't that hard to code because there was a few things like I didn't know how to read in documents and into R so it could like check them. But then I found the code and I was like, oh, there's a code for that. So number five. Here we are with number 5. Oh, we did something very similar to this. So number 5, we've kind of done. I'm trying to think of like how to help but not do it. That's always my goal, especially lately, is to like help but not do it. So with number 5 right here, I think where people are getting stuck because we have it in another video right now. And here I'll code the portion we have in the other video. So what we need to do, we'll code that really quickly here. We'll code the while loop. So let's get the while loop coded right here. So the while loop is going to check to see every time if what is in X is going to go through the first column right here. So it's going to go through the first column, and we're going to check the I, and we're going to start with I equal to 1. And then we're going to go right here, and we're going to do I plus 1. And then we're going to check to see if this is equal to 0. And so we can run this as not a while loop, and we can see where it would stop. Oh, am I not doing it? I did something. Oh, I'm rerunning the, haha. I don't want to rerun the store into I. So that's the first run, second run, third run stops. So this is the while loop right here, and I kind of ran it. So we see outside of the while loop, we store 1. And like I said, that's a common mistake. There's our condition. That doesn't go there. That goes here. So we have everything we need, and we can see at the end of this, question 3B, 3 or 4B would be awesome. Yeah, we might have enough time to do that. Let's take a look. Because I might, which one do you want, 3 or 4B? Because we have just, I'll mention it after here. So this, whoa, Prince 1, what happened? Print I. What did I do, Jake? Row 1, row 2. Did I not do it right? I had it working. So while, oh, wait. It's not equal to 0. There we go. There we go. There we go. There we go. You stuck on those two. 4B, we can talk about 4B. And I do have office hours tomorrow. Do not worry. We'll help out more. Do not worry. So this right here, I just had to switch the way the condition works because a while loop only runs if it's true. I was going quickly and my brain didn't think, okay, wait a minute. I need trues in here. Because what it's doing right now is it's checking this. Is this not equal to 0? True. Is this not equal to 0? True. Is this not equal to 0? False. And then the while loop stops on the third. Now, here's the thing that people are, at least what I'm seeing where people are stuck, is they need to put this into a for loop now. And when you put this into a for loop, who in the chat can tell us what will change? And so Jake and Emily pick 3 or 4B. Which one do you want me to do next? Because I'll have just enough time to do it because now it's preparing for 2 or 1. What will change about this loop when, like, what will we want the for loop to change? And this is the while loop right here. The three will change. But what, you're right, the end answer will change. But what about this loop will change right here? Oh, question 3. Ha. Sorry. I could not think. I was like, yeah, the 3, it will change. This will give a different answer. And this will change. This is the column. So we need to go to the second column, the first column, like, here's what the for loop's going to do for us. The for loop's going to do that. Then the for loop's going to do this. Then the for loop is going to do this. That's the answer. So that's the answer of what's going to happen. Did everyone see what the for loop's going to do? It's going to run it one time here. It's going to run it one time here. And then it's going to run it with this right here. That's what the for loop's going to do. Be very careful and try running it without the for loop. But this should get people part of the way through it. Question number 3, a matrix with 100 rows, 100 values. Write a nested for loop that defines each element of M to be the absolute value of the difference between all the rows. So the first thing to write is to write a function that finds the absolute value of the difference between the row we're in and the column we're in. So if you notice right here, so I'm going to drop some big hints right here. So I think this is the best way I can help out with this in the very little time we have left. This right here needs to be a placeholder, and this needs to be a placeholder. This is where I see people making mistakes, is you could think of this as the rows and the columns. So what might be good placeholders to put here for this and for this? What might be good placeholders for rows and columns? What might be good placeholders for the rows and the columns? Think about what would be good placeholders here. And so with this right here, and you can actually highlight all the code and hit Command-Shift-C. So with this right here, you want to put a placeholder here, right in this question mark, and you want to put a placeholder here in this question mark. Now here you have to go through all the rows, and here you have to go through all the columns, and here is the formula. So this question mark right here is the formula that will find the absolute value between the difference of the rows and the columns. So think about this. You have something that is, every time you run it, it's going to give you the row, and every time you run it, it's going to give the columns. And then you want to find the absolute value of the difference, and then you want to store it into the row column position in the matrix. So this right here is the rows, all the rows that it'll go through, like a sequence. This is the columns, all the columns it'll go through, another sequence right here. Then this is the position it stores into the matrix relative to the row and the column you're checking. And then this is the value it's storing, which is the absolute value of the difference between the rows and the columns. Who thinks they get this right here? Who thinks they are on track with this? Did that make any sense? Did that help out as I'm saying what each of these question marks are basically? This is the row placeholder. These are the values the row placeholder will go through. This is the column placeholder. These are the values the column placeholder will go through. This is the position in the matrix you will store into via row and column. And this right here is the formula finding the absolute value for the difference between rows and columns. Did anyone be like, that's where I made my mistake, or that's what I'm doing? Who's with me on this? Anybody? No. Hopefully somebody. Good, Emily. I'm glad to hear that helps. And definitely, because I don't want to give it away. I just kind of want to like give hints and be like, here's what you need to do. Here's how to kind of sleuth through it and get the final answer. And to be like, have that epiphany moment where you're like, okay, this is what this is doing. This is how it goes through these values. And I think that's got it. I will be back tomorrow. Good job, everybody. 201. We do have help in the other videos, and I will definitely will spend me more time helping with 201 tomorrow. They've got assignments coming up, and they've got lecture coming up. And should I play the Smash Bros? Yes or no? Let's see what Mubot has to say. I should just do it and see if Nintendo. I'll give it like a week or two to see if Nintendo hits us with a copyright claim. Truth, Mubot. That was a timely quote right there for playing Smash Bros. So with that, we will be back. We will be back. Email me questions if you have them. Great job, everybody. Great office hours. So many people here. I'm really honored by that. Keep up the good work and keep emailing me or Discording me questions if you have it. I will see everybody later. Bye, everybody. Bye.